Design of composite bridge. In this session we shall see the process to design the composite bridge with steel plate or box girder and RCC deck slab, RCC abutment, RCC pier, bridge POT PTFE bearings and creating the design drawings for construction. Step 1. Click on icon for ASTRA Pro R19 on the desktop. The ASTRA Pro main screen opens. Select menu item Process Design. Select menu item Select Working Folder. Select Working Folder Work on Desktop and click on OK. Step 2. Select menu item Process Design. Select menu item Bridge Design. Select menu item Steel Plate / Box Girder RCC Slab Composite Bridge. Step 3. The selection box comes. Select the design standard as British Standard BSI Eurocode2. Click on OK. Step 4. The design screen opens for the selected item. There are tabs for analysis of bridge deck, steel girder, deck slab, RCC abutment, RCC pier, bearing, and drawings. Open the tab Analysis of Bridge Deck. There are 5 more tabs under the current tab. These are User Input Data, Steel Plate / Box Girder Section Data, Result of Section Properties, Moving Load Data, and Analysis Process. Come back to tab User Input Data, click on button New Design. The new design folder is created as Design Job Number 01 inside the folder Work on the desktop. At all future times user may open the design by clicking on button Open Design and by selecting Design Job Number 01 within the folder Composite Bridge BS within the working folder Work on the desktop. Select the one after another and enter your own design data by replacing the sample data. User must not change the blue color data as these are calculated values. Select the tab Analysis Process, click on button Create Analysis Data. The input data for various analysis processes are created and message comes, click on OK. Next, click on button Process Analysis. The list comes with 8 different analysis process with various load combinations. Click on button Process. The process starts and dialog box comes, click on button Proceed. Message comes with total load cases, click on button OK. Next, main analysis dialog box comes to run SAP program, click on Proceed. As the process is over, message box comes with output file details. Click on button OK. The maximum forces is read for various members in the bridge deck model. The above procedure is to be repeated for all 8 processes. and at the end the analysis results will be read from all the 8 processes to get the highest forces generated in each member. At the end the analysis results are displayed on the screen for the design of members, and support reaction forces are shown which are to be used for the design of abutments, piers, and bearings. Step 5. Next, select the tab Steel Girder for the design of main steel girders, either as plate girders or as box girders. Under this tab there are 3 more tabs. These are Steel Girder Design Force Data, Steel Main Long Girder Section, and Design Input Data. User must not change any red color data, as these are taken from previous pages. Click on button Process at the bottom of the page. The message comes informing about the design report. Click on button OK and the design report is opened for viewing by the user. After viewing, close the design report. Step 6. Next, select the tab Deck Slab BS5400. There are 3 more tabs under this tab. These are Analysis, Design of Deck Slab, and Cantilever Slab Design. Step 7. The current tab is for Analysis. The various design data are displayed. Click on button Process 1 Analysis. As the process dialog box comes, click on button Proceed. The message comes for number of load cases. Click on button OK. Next the SAP analysis dialog box comes. Click on button Proceed. As the analysis is over, message comes by informing about the design report file. Click on button OK. Step 8. Next, select the tab Design of Deck Slab. Under these tab there are 4 more tabs as Design Loads and Forces, Transverse Bending Resistance, Flexural Cracking, Shear Calculation and Figures. Select tab Design Loads and Forces, click on button Process to Design. And the design is done by displaying the report part for this particular step. Select tab Transverse Bending Resistance, click on button Process 3 Design. And the design is done by displaying the report part for this particular step. Select tab Flexural Cracking, click on button Process 4 Design. And the design is done by displaying the report part for this particular step. Select tab Shear Calculation, click on button Process 5 Design. And the design is done by displaying the report part for this particular step. Select tab Figures where the various loadings are explained. Step 9. Next, select the tab Cantilever Slab Design. Under these tab there are 4 more tabs as Design Loads and Forces, Transverse Bending Resistance, Flexural Cracking, Shear Calculation, longitudinal, bending resistance and figures. Select tab Design Loads and Forces, click on button Process 6 Design. And the design is done by displaying the report part for this particular step. Select tab Transverse Bending Resistance, click on button Process 7 Design. And the design is done by displaying the report part for this particular step. Select tab Flexural Cracking, click on button Process 8 Design. And the design is done by displaying the report part for this particular step. Select tab Shear Calculation, click on button Process 9 Design. And the design is done by displaying the report part for this particular step. Select tab Longitudinal Bending Resistance, click on button Process 10 Design. And the design is done by displaying the report part for this particular step. Select tab Figures, where the various loadings are explained. Step 10. Click on button Create Design Report. This will create the design report by joining the design results of all 10 parts of the design results, and the full design report is displayed for viewing by the user. After viewing, close the full design report. Step 11. Next, select the tab RCC Abutment. Two separate designs are there for counterfort and cantilever abutments. The counterfort abutment is selected with the various design data displayed in the page. User may modify the data values as desired. Click on button New Design. The design will be done and the report in MS Excel worksheet will be opened. User has to wait for some time. Step 12. Next, select the tab RCC Pier. The various design data are displayed. User may modify the data values as desired. Click on button Process. The interaction diagram charts come. Enter relevant value by reading from the charts and click on button Process. The design will be done and the report will be opened. Step 13. Next, select the tab Bearing. The various POT/PTFE and bearings designs are available under separate tabs with the sample data displayed there. User may modify the data values as desired. Click on button Process. The design will be done and the report will be opened. Step 14. Next, select the tab Drawings. There are buttons relevant to various construction components in the bridge. Click the buttons to open the drawings. As the selection box comes, select Sample Drawings to open. the sample drawings and select design drawings to open sample drawings with converter to convert the sample drawings to design drawings by opening the design report and related drawing and by changing the values there. The drawings may be saved as DWG or DXF to make them compatible to AutoCAD or other CAD softwares. As the process is over, close all the design pages. Step 14. Next time by opening ASTRA Pro. Select Open Design and select the previous design as design job number 01 to open the particular design for any modifications as desired.